Good day. Today we want to consider vector. But before we look at vector, it's important to note that physical quantities can be classified into scalar quantities and vector quantities. Classifying physical quantities into this, what we consider basically are quantities that have directions and the quantities that don't have directions. There are other ways to classify physical quantities, such as fundamental quantities and derived quantities, and dimensional quantities and non-dimensional quantities. But all of those other classifications are not what we are considering. We are classifying physical quantities based on the quantities that have direction and that which do not have direction. And so we have scalar quantities and vector quantities. Though this is what we want to basically consider today, but it's important to talk about scalar quantities as well. Let's introduce what scalar quantities is. Scalar quantities are those quantities that have magnitude but no direction. Example is mass, length, time, temperature. You can say distance as well, though length should substitute distance, but anyhow you say it, length, distance, they are all scalars. Speed, energy, pressure, density, all of these are scalar quantities. One of the most questions you'll be seeing under this is, which of these quantities are scalars, or which of these quantities are vectors? Which of these quantities are not scalars? Which of these quantities are not vectors? Well, so that's why we introduce the scalar quantities. Now let's go into vectors, which is what we happen to want to do today. So what are vector quantities? These are quantities which have both magnitude and direction. While scalar has only magnitude, it doesn't have direction. But vector quantities have both magnitude and direction. Example is displacement. Now, one thing I want to take note here is that displacement is kind of synonymous to distance in scalar. The difference is that while distance has only magnitude, displacement doesn't have. While distance has only magnitude, displacement has both magnitude and direction. What I mean is this: you can ask, or someone says a man moved at a distance of 20 meters. That's just distance. But when you say somebody moved somebody covered a distance of 20 meters east, 20 meters west, 20 meters south, 20 meters northeast, when you are putting direction to the distance someone moved, then it becomes displacement. So while displacement has direction and magnitude, distance has only magnitude but no direction. Another one is velocity. Velocity is synonymous to speed in scalar. Velocity means speed in a particular direction. When I say the speed of this car is 20 meters per second, that's just speed. If I say the speed of this car is 20 meters per second to the right, to the left, to the north, to the south, you are putting direction to the speed, then it becomes velocity and no longer speed, because you now have direction to that speed. Now we have also acceleration under vector quantity. We have force, moment, electric field intensity, momentum, magnetic field, gravitational field, etc. Representation of vectors. You see, vectors are represented with lines which correspond to their magnitude. So if a vector is small, you have a small line. If a vector is big, you have a longer line, a bigger line. Now, it also comes with an arrowhead. You see, look at this vector now. We don't know its direction. But if I'm putting an arrowhead here, that tells me this vector is going like this. If I put an arrowhead here, then this vector is going down. So if I draw a line, that's not enough to represent vectors. You have to put an arrowhead that shows the direction. So while the line shows the magnitude of the vector, the arrowhead shows the direction of the vector. Now, next we want to consider is addition of vectors. When you add all vectors together, what you get is what we know as the resultant vector. So the resultant vector is that single vector that has the same effect in magnitude and direction as when you add other vectors together. Is that single vector that is the sum of all other vectors together. That is what the resultant vector is. So let's see how to get the resultant of two vectors. Now, the method to use in obtaining the resultant of two vectors depend on angle of inclination between the two vectors. Well, we consider various cases here. Case 1, resultant of parallel vectors, or resultant of vectors that either 0 degree or 180 degree to one another. It's important to note that if two vectors are parallel to one another, they are either 0 degree to one another or 180 degree to one another. Let me explain this now. Let's say, for instance, this is vectors now, and this black cover happens to be the head, and this happens to be the tail, actually, because a vector has head or tail. This is the tail, and this is the head. And so, let's assume this is the head and tail, and this is another vector having the head and tail. If I put these two vectors like this, what should be the angle between them? The angle between these two vectors should be 90 degrees, approximately. Now, if you bend these two vectors like this, they should be at an angle of, let's say, 60 degrees. If you bend again, it should probably be 30 degrees. If you close it down like this, these two vectors are 0 degree to one another, and they are parallel. It doesn't matter if they are like this to be 0 degree. They can be like this 0 degree. They can also be like this, still 0 degree. They can face like this 0 degree. They can face like this 0 degree. They can face like this 0 degree. One thing that matters about vectors that 0 degree to another is that they are parallel and pointing to the same direction. Now, look at this vector again. Let's say they are like this. We know it is 90 degree. If it open up a little bit, you say it probably should be 120. If it open up further, you say it should be 180. If you bend it like this, it should be 150 like this, and then 180 when it's parallel. Now, the difference here, though parallel, is that they are parallel and moving in different directions. One is pointing towards the direction, and one is pointing towards the direction. It doesn't matter if it's like this. They are still 180 degrees to one another. Parallel, but in different directions. Because this head is pointing this way, and this head is pointing this way. And so you can see that when vectors are parallel, they are either 0 degree or 180 degree to one another. Now, one important thing you need to take note of here is how to get the resultant of parallel vectors. When two vectors are parallel to one another, their resultant can be gotten by mere algebraic method. For instance, look at these two vectors. Let's say they are parallel. What angle would we say these two vectors are? Well, parallel and in the same direction. So therefore, they are 0 degree. Now, if they are 0 degree to one another, how do you get the resultant? Just take this vector, add it to this vector. That's just all. And they'll be pointing in this direction because that's the direction of the two vectors. Now look at this vector again. E and F. Let's assume they are parallel. Obviously, because they are pointing in the same direction, they should be 0 degree to one another. How do you get it again? Just sum up the two vectors. That's just all. And this will be the direction, because that's the direction of the two vectors. Now, look at C and D. These two vectors are also parallel. And how do I know? They are pointing in the same direction. And so, I know they are 0 degree to one another. And so, because of that, resultant will be equal to C plus D. Just adding them together. That is the resultant. So, let's say, for instance, now, I have a vector like this. I want a vector like this. And this is 4 Newton. And this is 5 Newton. What will be the resultant? The resultant will simply be 4 plus 5. And that's 9 Newton, pointing upward. One thing to note about this is that when vectors, the resultant, of two vectors is maximum when the vector is 0 degree to one another. So when vectors make 0 degree to one another, they have the highest resultant. No other angle will give you that maximum resultant than 0 degree. Now look at this now. These are parallel vectors, but at 180 degree to one another. And how do you get the resultant? You subtract the bigger minus the smaller. Now, because the A is longer, we assume the A is bigger than the B. So it will be A minus B, and in the direction of the bigger vector. And so this is C minus D, assuming that C is bigger. So C minus D. Look at this now. F is longer than E, so it will be F minus E in the direction of the bigger force, which is the bigger vector, which is F. Now, for instance, let's say we have two vectors like this. 9 meters per second, and I have another vector like this, 7 meters per second. Then their resultant is going to be 9 minus 7, because they are parallel but in opposite direction, and that's 180 degree. And this will give us 2 Newton. One thing to note here again is that the resultant of two vectors is smallest or minimum when they make 180 degree to one another. So if two vectors make 180 degree to one another, they will have minimum or the smallest resultant, and they will have maximum when they make 0 degree to one another. So you need to take note of this. Let's now look at the resultant of vectors that incline at an angle that is not 0 degree or 180 degree. I call them non-parallel vectors. Resultant of non-parallel vectors. You see, when two vectors are inclined at an angle which is not 0 degree or 180 degree, then the resultant can be obtained by parallelogram law, by triangle law, or method of resolution. There could be other methods actually, but I'll be focusing on parallelogram law. Now, it says that two vectors can be represented by a parallelogram, and the resultant of these two vectors is simply the diagonal of the parallelogram, which is drawn from the point of intersection of the two vectors. Now, there are certain things one needs to understand about parallelogram, and I'll be showing all of those here. Now, first and foremost, this is a parallelogram. This is a parallelogram. Now, one important thing to note about a parallelogram is, one, that opposite sides are equal. Meaning, if this is a vector and this is a vector, and you use a parallelogram to represent this vector, whatever this vector is, if it is A, here also will be A. If here is B, here also will be B. If this is 10 Newton, here will be 10 Newton. If this is 20 Newton, here will be 20 Newton, because opposite sides of a parallelogram are equal. Now, number 2 is that opposite angles of a parallelogram are equal. Meaning that, you see, if the angle between these two vectors is 30 Newton, for instance, opposite angle here should be 30 Newton. If this place is 60 degrees, angle here will be 60 degree. Whatever the angle here is, if it is theta, here also will be theta. And you see, angle here is also opposite to angle here. So if here is beta, this place should be beta. If here is 120, here should be 120. Whatever it is, actually, opposite angles are equal. And number 3, adjacent angles are supplementary. Now, take note that two angles are supplementary if they add up to make 180 degree. Now, what are adjacent angles? If you add up this theta plus this beta, you should have 180. That's what it means. Or this plus this, you should have 180. So it means that, for instance, let's clean up these angles again. If here is 60, we said the opposite angle should be 60, here should be 60. You have it in mind that here should be 120. How do I get that? 180 minus the 60, and that will give me 120. That's what I'm trying to say. And here too should be 120, because 180 minus 60 should be 120. If you add this angle to this angle, you should get 180. That's the point. Or adding this angle to this angle, you should get 180. So that's what the properties of a parallelogram. Now, another property of a parallelogram is the diagonals. A parallelogram has two diagonals. The one taken from here to here, and the one taken from here to here. Now, these two diagonals doesn't represent the resultant. Only one represents the resultant. And let me show you how you know that one. It is the two vectors now. Now, this is where they meet. This is the point of intersection. So if you make this in a parallelogram now, the diagonal drawn from here is what is the resultant, because this is where they meet. So it depends on how the two vectors meet actually. If the two vectors are like this, for instance, initially given to you this way, and then you make it a parallelogram, then the diagonal drawn from where they meet here is the resultant. So it is the diagonal drawn from where the two vectors meet. That's what represents the resultant. And so that's what parallelogram law is simply saying. It simply states that if we have two vectors, let's say this is the two vectors, and you make it a parallelogram. I'm trying to show that this is just the same as this, but this is the two vectors actually. That's why I use dotted lines or broken lines for the other part of the parallelogram. See, if this is A, or this is C, vector C, and this is vector D, here will also be C, and here will be D. Now, the line drawn from here is what represents the resultant. This is the resultant in magnitude and direction. This can be solved graphically, but we have other method of solving which is not graphical method. And that is because you often may not have your graph always. You still want to find the resultant of two vectors. Well, you can use method of trigonometry to get this, and that is the cosine rule. I'll be showing you the cosine rule briefly. So let's take the cosine rule. It's often used for a triangle. Let's assume that the angle of this triangle is A here, and the side facing it, the side of the triangle that is from here to here, facing this angle is side A. And let's assume that this is angle B, and the side facing it here is C. Sorry, B. And let's assume this angle C, and the side facing is side C. Now, the cosine rule simply states that C, if I'm looking for A, let's say I'm looking for A, I'm looking for this side, A, is simply equal to B squared plus C squared minus 2 times B times C cos angle facing that A, which is small letter A. And if it is B you want to get, that B squared will be equal to, then square, I'm looking for this side then square this side, that's A squared, plus square this side, that's C squared, then minus 2 times the same side A times sine C, side C, sorry, then multiply by cos angle facing this side B, and that's angle B. And if you are looking for side C, that will be C squared is equal to, I'm looking for this side, A squared plus B squared minus 2AB cos angle facing the side C, which is angle C. That's the cosine rule. So let's solve this question using the parallelogram law and then getting the resultant by trigonometry. Now, pay attention. Example 1. Find the resultant of the two vectors below. The first thing I will do here, solution, is to make this a parallelogram. (9 Newton and 7 Newton). Okay, this is 7 Newton as well, and this is 9 Newton. And so the diagonal jump from point of intersection is the diagonal here. Is what represents the resultant. Now, if you watch carefully, this is like two triangles. We have the upper triangle and the lower triangle. And so you can use any triangle and apply cosine rule to it. And that would be, let's take the upper triangle for instance. That will still give us the same answer, even if you take the upper or lower triangle. But this is 7 Newton and 9 Newton, and this is the resultant. Now, mind you, the angle here was 60 degrees. So what will be the angle here? Adjacent angle as supplementary, that means they add up to make 180. So to get the angle here, you have to say 180 minus 60, that will give us 120. Angle here will also be 60. And the angle here is 120 as well. So I'm going to have here being 120. Now, what's the angle here? We're not given actually. But you see, angle here alone, just here alone, you can call it alpha. An angle here alone, you can call it beta. An angle here, you can call it beta. It should be beta because it alternates to this. And the lower angle here should be called alpha because it alternates to this. So this is, taking the upper triangle, this is the alpha, and this is the beta. So right from here, you can say r squared is equal to square of the other side, 7 squared plus 9 squared minus 2 times 7 times 9 times cos of angle opposite to this r we are looking for, which is cos. Sorry, in the question, this is 60 degrees, please mind you, this is 60. So this should be, this is 50, sorry. This is 130. And this is 130, please. That's a mistake. And this is 50. So this is 130, please. And so times 130, cos 130. So this is 49, 7 squared plus 981 minus 2 times 7 times 9. That is 126. Then cos 130 is minus 0.6428. It's a negative value actually. Now, here 49 plus 81 will give us 130. Now, minus times minus will give us plus. So 126 now multiplied by 0.6428. That's approximately 81. So r squared is equal to 130 plus 81. That's 231. So 211. And then r is square root of 211. And that will give us 14.53 Newton. So that's the answer for this. Well, if this question was to be an OBJ question, I don't need to go through this process. In order to be fast, how do I solve this question? If it's an OBJ question that doesn't require my solving, I'll just simply say r squared is equal to 7 squared plus 9 squared, the 2 vector, minus 2 times 7 times 9. Cos, I will come here and say 180 minus 50. That's what I'm going to do. And that will be 7 squared plus 9 squared minus, this should be 126 cos 130, and then you can solve. You actually get the same thing actually. But that's without putting up this diagram and following parallelogram law. You just want to be fast because your exam can be OBJ. So that's about that. We're not required to get this alpha and beta, but if you also want to get the alpha and beta, then you have to use sine rule. Now you've gotten your r, and your r is 14.53. You can now say sine alpha over 9, sine alpha over the one side opposite to that's 9, is equal to sine beta over what now? Sine beta over 7. And that will also be equal to the r, which is 14.53, over opposite to it, sine 130, sorry, no, I'm wrong, sine 130, sorry, over the R, which is 14.53. And that's all. So if you want to get your alpha, equate this and this. I mean, I want to get alpha now. Just say sine alpha over 9 is equal to sine 130 over 14.53. And solve till you get your alpha. If you want to get your beta, also equate this to this. That means to say sine beta over 7 is equal to sine 130 over 14.53. So that's all actually about solving this. You can get your alpha, you can get your beta. It's not required, but I'm just trying to throw light on that. So that's about this example. Let's take another example. If two vectors, 12 Newton and 7 Newton, makes an angle of 120 degrees to one another, find their resultant. Well, let's solve this question now. And so here we're going to have, we have 12 Newton and 7 Newton. And so their resultant, let's make this a parallelogram. Okay, so this is 12 Newton and this is 7 Newton. And the angle between them is 120 degrees. So this should be the resultant. So let's take this triangle now to get the resultant. So this is the 12 Newton, this is the 7 Newton, and this is the resultant. Well, because here is 120, this should be 60, and here should be 60. The whole of this should be 120, so here should be 60. I'm looking for the resultant. Obviously, using cosine rule, we know that r squared should be equal to 12 squared plus 7 squared minus 2 times 12 times 7 times cos 60. And so 144 plus 49 minus 2 times 12 times 7. This is 168 into bracket cos 60 is 0.5. And so this is going to be 193 minus, this is going to give us 64. And this will be 193 minus 64. That will give us 129 r squared. So r is square root of 129. Let's quickly get that now. .36 Newton. That's our final answer for this question.